Welcome, welcome. I'm so glad you're here. We have a great topic today, and I'm excited about the interest in it. If you are a regular webinar attendee, then you've probably heard this before, but we have so many new folks tuning in that I need to level set. If you're signing up for these webinars, then that means that you want to get more done, you want to move faster and produce higher quality so that you can deliver for your team, your company, your customers. And this series is .NET DevOps for Architects. It's guidance aimed at software leaders who want to enable their teams to be world-class. And I know from experience that if you map out your software delivery process and then automate it, you will deliver more, and you and your team will absolutely love programming again. But we have an enormous problem, a serious problem, and a problem that we're going to have to solve. Most teams automate work for their own customers by producing software, but then they saddle themselves with new administrative work to build, deploy, and monitor software that relieved customers of their administrative work. There's no reason that the cobbler's kids shouldn't have shoes. I work with teams all the time where one of their most senior, most capable developers is trapped by the task of deploying the software because he's the one who understands the software the best. So they take their best talent with the most experience with the software and reduce them to weeks full of administrative tasks. A deployment is a set of administrative tasks. You're copying files, you're changing a config file, configuring a credential, starting a service, and then doing it again over and over and over again. We all got into software because we saw the tremendous power available. We can write code and make the computer do something that makes ours and others' lives better. So then we shouldn't settle for a process that takes people with technical creativity, you, and turn them into an automaton. And for you managers listening in, I want to share with you what goes on in the brain of your people who have to do these manual processes over and over. We as humans are always on a pursuit of happiness and significance. And whether we get fulfillment in serving others or making something new, your people aren't finding happiness in the process of manual builds, environment configuration, and deployment. They want to get it done as fast as possible so that they can get back to why they got into software in the first place, to create things, to solve interesting problems, to make others' lives easier through software. And as a result, the manual tasks are error-prone. They're not interesting. And the more your staff endures tasks that don't bring happiness and satisfaction, the more they become open to maybe considering other employers that might be able to provide more work that does bring satisfaction. So whether you're an individual developer, lead a team, or are a manager in technology, this series is for you. Now, last week we had an overview of the whole architecture of DevOps, and I'll briefly touch on that. Next, we'll go through the common mistakes and the 3 critical elements of any version control repository. And finally, I'll show you how to get started. Now, I want to give you something of value. And so my latest book, .NET DevOps for Azure, is available for pre-order on Amazon. But I want to give that to you now. I don't want you to continue to be frustrated and sometimes trapped by the software that you work on that seems to always find a way to break upon deployment. I do understand the lost weekends and the surprise overtime due to software builds and deployments going poorly. And so at ClearMeasure, we've helped over 100,000 professionals across over 40 countries be better at software. And my book, .NET DevOps for Azure, exposes the secret about how any team can have a fully automated DevOps pipeline by following a concrete 7-stage design. And so here's what you need to do. First, read my book, and I'll give you a free ebook copy just for being here today. So send me an email and I'll get it to you. In fact, if you put it in the chat, then I'll get it to you. Either way. And if you're catching this recording, yep, the offer still stands. Reach out and send me an email. Step 2, understand the 7 stages of a DevOps pipeline, which is in the book, so you got to read it. And step 3, launch your pipeline, and use our public project as a model. You'll find it in the book. If you do this, you will have a fully automated DevOps pipeline using Azure DevOps services that will enable you to move faster with higher quality, and you'll be able to run your systems with confidence. And for the print book, you can pre-order on Amazon with the link here. And also, I am giving a hands-on, deeply immersive bootcamp style training course at the end of October. And some seats are still available, and so you can sign up there. All right. If you have any questions about the bootcamp, you can go to bit.ly/.NET DevOps Bootcamp. That's bit.ly/.NET DevOps Bootcamp. And if those dates don't work for you, or if you'd like a private course just for your team, then reach out and we'd be happy to get that set up. An additional resource, as always, is the Azure DevOps Podcast. You can go to www.azure-DevOps-podcast and podcast.show and see past episodes and show notes and subscribe with any podcast directory. Now, these are the 7 key elements of a DevOps environment, and we are on version control system structure today. And next week, we'll be going deep into the build process. That includes private build and continuous integration build. And by the way, if you have not read that 2006 book on continuous integration, then make that required reading for your team. Now, just a quick overview. Our overall DevOps model we call Onion DevOps architecture, and the principles is that each of the cycles in your DevOps process is represented with concentric circles, with the faster cycles toward the center and the slower cycles on the outside. So each layer is a cycle, and each layer is executed through the same pattern as test-driven development: arrange, act, assert, or define, do, get data, whichever one you prefer. Inner cycles spin faster than the outer cycles. So the coding is your fastest cycle. You need a really fast coding cycle, and then engineering or team is your pull request cycle. The product is your manual testing or putting out internal releases for product management, and product management defining new features that they want to push into a sprint or a cycle. And then strategy is determining what big pieces of functionality to deliver for the customers, and then doing market testing. So these are all cycles, and the outer cycles, just like a solar system, the outer cycles are larger and spread out, and the inner cycles are really tight. And each of these layers has to be a complete cycle. There has to be the define or the analyze before you do something and then check it. The design is kind of like a hypothesis that begins the cycle, and then verification completes it. Okay. And no organization is going to have fewer than these minimal cycles, and your organization may have more. Okay. So DevOps gives us that model to ensure that we identify all the needed elements. And remember, the key principles of DevOps as a whole are flow, feedback, and learning. So flow is pushing things forward and getting releases out and getting code to our customers. And feedback is all the testing and verification and static analysis and all the checks to make sure that we aren't just shipping defects to production faster. And then learning is making sure that every step of the way we have data in the form of metrics that's coming back to the design element of that particular cycle. All right, so on the inside, we're going to dive into code, because version control repository really affects the inner cycle of coding. And in this element, we're asking the questions: what does done mean? How can I get it working quickly? How do I detect and prevent defects? How do I stay aligned with the architecture? What practices do we use? Things like that. And so with the whole process, we are in this center line where we've done the 4 elements of pre-code design, and then we're hands-on keyboard, and we're working with our, and I'm just going to say Git repositories, because even though other version control systems do exist these days, Git is kind of the become the industry standard. So I'll use those interchangeably. And then working on the source, we have a build process and release candidate. So this area is what we're talking about today, this area of the whole process. All right, so mistakes. Don't open Pandora's box on your DevOps pipeline. Now, what I mean by that, if for those who haven't heard the story of Pandora's box, is that once it was open, these evil spirits got out and they could not be put back in the box. Once you create a version control structure of an application and get it shipped and you're in production and you've made some mistakes and you've got a lot of work built up, you've kind of painted yourselves in the corner, and it's going to be a lot of effort to refactor it. Now, one of the ways that you can paint yourself into a corner and make a big mistake is taking an older TFS or Subversion repository that has an entire tree of software systems where every folder was an independent application, and then just importing it into a Git repository. If you are migrating from Subversion or from Team Foundation, version control, or Perforce, there's many other systems that had a structure where you could have multiple projects in the same top level repository, because they overloaded the term repository, and they really should have meant Subversion server, and the repository was kind of like the server, and then each folder is really a repository. Git said, you know what, we're not even going to mess with this collection concept, and we are going to have every repository be one level down. So the different technologies use the word repository in a different way. But suffice to say, when you get to Git, every Git repository needs to be a single application. And so a mistake you can make is putting multiple applications in the Git repository, because then you try to trigger a build automatically once you get to continuous integration based on a change of a Git repository, and then every level is triggering a change, and then you're trying to figure out how to configure a build on only a part of that Git repository, and then you're trying to use branch filters all over the place, and it is an absolute mess because the tooling was not designed to work that way. So avoid that mistake of just migrating older, really large multi-project version control structures into a single Git repository. So that's a mistake you can make. Another mistake you can make is setting up the Git repository with incomplete source. And there's 2 ways that you might have incomplete source. One is if you use Git submodules and try to link multiple applications together using submodules. Now in Subversion, you also had Subversion externals, and that feature, if you're migrating that in, that's a feature. It's documented. It works. You can use it. Most of the time, you don't want to use it, and it's a mistake. Now, if you have a specific situation in which only that will work and you know exactly why, and you're willing to absorb the overhead of managing it, okay, go for it. But for the most part, most of the time, don't use Git submodules. You want the complete source in a Git repository, okay? So including incomplete source and thinking, oh, I need to enable reuse by linking the source of another piece of software in using a submodule. Enable reuse by publishing a package and then consuming it via NuGet. In the Microsoft and the .NET world, NuGet is the protocol of reuse, okay? Not raw source. All right, the other way that you could make the mistake about incomplete source is with how you manage packages. Now, on day one, if you're creating a brand new service or a brand new application, then NuGet package restore works perfectly fine. Whether with MS Build or with .NET Core, use .NET, the command line .NET and restore, and all the packages come in, and you don't have to put those packages in your own version control repository. On day one, that works great. And while you are on daily active development, then that works great. You will encounter situations where some second level dependency changed on you and there's some compatibility issue, and then you need to fix it. And the cause was actually a new version of a package that just came in and now caused a problem. But because you're in daily active development, that's no problem. Now, once you move out from daily active development of a particular Git repository, you need to commit, you need to do one of two things. You need to secure all of those NuGet packages. You can do that in two ways. One is you can commit them to your Git repository, and that way you ensure that you have 100% of the dependency chain that your code relies on. The second way you can do it is to create an internal private NuGet server where you cache all of those packages in the chain that your application relies on, guaranteeing that you have those exact versions and that they're not going to change on you. There was a big issue in the NPM community where a string library changed, and it was a popular string library, and everybody just happily got the new version of the string library, and it broke everybody. That can happen with package managers because part of your source is dependencies, and the more you don't control it, the more risk you open yourself up to. And so especially for legacy applications, and when you move from active development to more seldom development, you need to change how you think of the relationship between package flexibility and risk, because they are trade-offs. Okay, so here's the 3 essentials that you have to have in your version control repository, okay? 3 essentials. For a particular Git repository, you need to have one and only one application in that repository. Now, let me tell you what an application is, because sometimes that term can be overloaded. An application is one piece of software that has a name and has a version number. Okay, let me give you an example. There could be a work order application, but it could have multiple components. In the .NET world, it is one Visual Studio solution. Okay, one application, one Visual Studio solution, and it's going to have possibly a web application. It could even have a web API project that runs as an independent application. It could have a Windows service or an Azure function, and it likely has a data store, a SQL Server database, or some other type of data store. And all that is one application. It is one thing. You deploy it together. It has the same name. It has the same version number. And so one application can have multiple running processes in production, but it is one application. It changes at the same cadence. It is deployed together, and the projects have dependencies. And even if maybe it's technically possible to deploy just one piece some of the time, when you set up a new environment, you deploy all of it together. And that's normal. All right, one application per Git repository. The second essential is that you can quickly build from scratch. That to set up a new developer on your team or a new workstation, you do a Git clone and run click-to-build.bat or whatever your shortcut file is that you can quickly type on a command line or double-click with a mouse, and it builds that application from scratch. And if there's a particular setup on the workstation and it fails, it tells you exactly which dependency. And in some cases, looks and checks for those dependencies and sets them up with Chocolatey or Box Starter automatically. Now, let me tell you why this is important. And by the way, I'm not talking about a computer that doesn't have Visual Studio installed or doesn't have the SDK. In your team, you're going to have a set of normal dependencies that would never fit in a source control repository. But if you need some particular thing installed locally, then your build should check for that and should tell you, hey, I'm failing because this prerequisite isn't present. But how many times have you onboarded a new developer onto your team and it took way too long just to get them to the point where they could run the software on their box? And it happens all the time. And it sucks valuable time and resources. And so when setting up your version control system, that's your goal. That's your primary directive. just to get started, regardless of the features that are going into the application, because other people are going to come down the line and you need to make it quick to get started, especially with so many. The problem is exacerbated in this new world where so many people are developing smaller applications. And whether you jumped onto the microservices buzzword or not, people are developing more applications, more Git repositories, and they're smaller in nature, but because they're separate, each one of them has, in some cases, different dependency chains. There's various platforms. We see Git repositories in the same software system using Angular and React or NPM, and then .NET and C# and TypeScript. And so there's different technologies, and we need to be able to go and clone an applications repository really quickly, run the build locally, and get up and running so that we can work with it, as opposed to trying to remember, oh shoot, what are all the steps to get this one working? All right, then step 3, and this is an ongoing thing that you need to think about, is minimizing the time from the time you do a pull from your Git repository to the time that you can run tests. And so whether it's just regular dependency management, whether you're doing a pull or a clone for the first time and you want to run the test, or whether a pull request was just accepted and now other team members are going to do a pull and then they need to get to run the test. If there is a new dependency, make sure that that's in there so that when your other team members pull, they have everything they need to. Make sure that cycle time is as short as possible. If running your tests, even component level integration tests, requires changes to your database, make sure that database migration process is part of your private build script that is executed with your click-to-build.bat, and which, by the way, is just a pattern. click_to_build.bat. That pattern's been around for a long time. Just as a helper method, it screams out to you, "Hey, run me in order to run my private build," but whatever your team decides on. So you want to minimize that inner cycle of getting new source and then getting to the point where you can run your test. So if a team member added a new column to the database, then you want to make sure that your private build process does an automatic database migration or recreates your local database on your box, so that when you run the tests that depend on that new column being there, it's automatic. All right. Those are the 3 essentials. Now let me share an example of a good one. All right. So this is the version control repository of the example from my book. It's the Onion DevOps Architecture repository. And I don't have the source expanded, but there's a Visual Studio solution in there, a very simple one. And you can see our click-to-build.bat, and you can see a build.ps1, which is the private build. And you can see a tools directory where, in this case, Octopack, and if you need to commit 7-zip or any particular tool that you just need to be there for access from the build, things that need to be there before you can run a .NET restore, for example, you put in the tools directory, and then source your Visual Studio and each project goes there. Your build functions.ps1, those are helper PowerShell functions. Open.bat, it's just a helper file that opens the solution in Visual Studio. And then private build.ps1 is the helper for private build, and then a README. So that is the overall top level structure of a version control repository that is set up for the pit of success for DevOps automation. Now, let me just show you what's in this click-to-build.bat file. That's it. It just chains over and adds an ampersand pause, so that if you double click with your mouse, the command window stays up. Now, if we were to dive into the build.ps1 file, and by the way, I encourage you to go to this public repository and look at the source for yourself. I'll give you the URL at the end, and it is the public project that is the source, the example of my book. But if we dive into build.ps1, I don't have enough room to show every line of PowerShell, but these are the functions. Your private build, the init function, basically deletes your old build directory, deletes the old repositories, and that is where you would do any dependency checks. If you need to have a particular version of the .NET SDK or a particular version of Visual Studio installed on a local box, just that's where you throw in an easy check and fail the build right there with a good error message just to help out your team members. And then compile, that's going to have your msbuild.exe call, or that's going to have your .NET build call. Unit tests are going to run your tests that do not call out of process. Integration tests are going to run your component level integration tests that do call out of process, but are still pretty quick. And your data layer, those you want to test all of your queries to the database that this application owns in your integration tests. And then migrate database local, that's where you build, that's the function where you rebuild your local database, and that goes in there. And then migrate database remote is a common variation where you can pass in the location of the database if it's not assumed to be localhost. And then pack, that's a helper where we can debug the packaging logic locally, but it's really used by the continuous integration build. And so our private build is these functions in sequence and wrapped with a little stopwatch so we can easily see how long our private build is taking and monitoring the length of that. And you can get the full build script and take it and copy it and use it to your heart's content. This build script and the general structure, I think its origins, I can trace its origins back to 2006 when the common technology in the .NET space was NANT. And I know that it came from some Java Ant scripts. And so this general structure is tried and true in the industry, even if you use PowerShell, or it doesn't matter what kind of scripting you use. So that is what you really need to think about in version control. It's not complicated, but if you don't think about these things intentionally, then you're going to paint yourself into a corner. Now, next week, we're going to be talking about build, both private build and continuous integration build. Okay, so you don't want to miss that. But right now, if you're trying to catch up, this is what to do next. Remember, send me an email so that I can send you a free copy of my book if you haven't already done that here in the chat with Rain. And as you read the book, use the included Azure DevOps Services project and source template and literally get up and running within a day. Also, be sure to subscribe to my podcast, the Azure DevOps Podcast. You can find it in any directory. And you can also go to bit.ly/.NET DevOps project to see that public project to clone right now. You can find me on Twitter at Jeffrey Palermo. Kind of blocking a few of the letters here. And my email, jeffrey@clear-measure.com. And next week, make sure to tune in as we dive into how to design your build process and frankly, how all the quick starts get it wrong. So if there's any questions at this point, then we'll take those and hang out. I know that I answered some of the questions in line, and tons of questions coming through getting the book. I'm really glad that you guys are taking advantage of that opportunity. The print book, that you can pre-order it now on Amazon, and it'll get to you in probably over the next month. But the ebook, we can kind of get you an insider preview copy of the ebook right now. All right. And I want to thank you very much for your time, and I'll leave this slide up so that you can get down the information, and I hope you all have a great day. We'll see you next week.